In this final section, we need to consider virtual private networks, because virtual private networks and tunneling is used to package or encapsulate packets and transport them inside of another packet or packets from one internetworking domain to another. A VPN enables the shared internetworking resources to be used as a private or dedicated circuit, part of our access control. Types of VPNs can be LAN to LAN, remote client access, or clientless remote access. Examples include things like point-to-point tunneling protocol, PPTP, Layer 2 tunneling protocol, L2TP, MPLS or multiple protocol label switching, generic routing and encapsulation, GRE, IPsec, which is an Internet Protocol Security, and Secure Shell, SSH. When you look at point-to-point tunneling protocol, PPTP, if you want more detail, it's at RFC 2637, a protocol which allows point-to-point protocol to be tunneled through an IP-based network. PPTP packages data within PPP packets, then encapsulates the PPP packets within IP packets for transmission through an internet-based VPN tunnel. PPTP supports data encryption and compression, and PPTP also uses GRE to get data to and from its final destination, and this should be enabled on Cisco routers. Layer 2 tunneling protocol, RFC 2661, is a protocol which allows PPP point-to-point protocol to be tunneled through an IP-based network. It is a hybrid of PPTP and Layer 2 forwarding, L2F, and can support multiple protocols. It's often combined with IPsec for security, and just for interest sake, it adds 42 bytes onto the packet, allowing tunneling of IPsec via NAT. Multiple protocol label switching, or MPLS, is a tag switching and operates at Layer 2. It's a data carrying mechanism operating at the data link layer. It was designed to provide a unified data carrying service for both circuit-based clients and packet switching clients, which provide a datagram service model. Multiple protocol label switching, or MPLS, is a mechanism in high-performance telecommunication networks that directs data from one network node to a next based on short path labels rather than long network addresses, avoiding complex lookups in a routing table. The labels identify virtual links or paths between distant nodes rather than endpoints. MPLS can encapsulate packets of various network protocols. MPLS is a range of access technologies including T1E1, ATM, freight relay, and DSL. And when we look at GRE, or generic routing encapsulation, RFC 2784, this is a network layer tunnel that allows any network protocol to be transmitted over a network running one or some other protocol, such as transmitting multicast datagrams over a unicast network, transmitting non-TCP IP routing protocols such as AppleTalk, IPX, etc. GRE can be a security issue that is packet filtering, so recommend a GRE be created in front of a firewall. IPsec suite, which is an open standard, is really important for the CISSP exam. It operates at the transport layer, where the authentication header provides connectionless integrity, data origin authentication. ESP provides confidentiality through encryption, which is the encapsulating security payload. The application layer, RFC 4306, contains the IKE, which is the Internet Key Exchange, which is performed using ICMP, Internet Security Association Key Management Protocol. Now, the open standard, the authentication header, provides a connectionless integrity and data origin authentication for IP datagrams and provide protection against replay attacks. When you look at the data origin authentication, this is where you need to understand that we cannot NAT IPsec, as the source and destination does not correlate anymore. The encapsulating security payloads provide confidentiality, data origin authentication, connectionless integrity, and anti-replay service, a form of partial sequence integrity, and limited traffic flow confidentiality. The security associations provide the bundle of algorithms and data that provide the parameters necessary to operate the authentication header and or encapsulating security payloads, the ESP, operations. The Internet Security Association and Key Management Protocol, ICMP, provides a framework for authentication and key exchange, with actual authenticated keying material provided either by manual configuration or pre-shared keys. Internet Key Exchange, ICE version 2, Kerberos Internet Negotiation of Keys, KINK, or IPsec key DNS records. The authentication header, which is referred to in RFC 4302, where the authentication header follows right after the IP header. The next header identifies the protocol of the transferred data. There's a payload length attribute which defines the size of the authentication packet. SPI identifies the security parameters in which combination with the IP address identify the security association implemented with its packet. The sequence number used to prevent any replay attacks, and also the authentication data contains the integrity check value or the ICV to authenticate the packet. And then the encapsulating security payload referred in RFC 4303, where the ESP operates directly on top of the IP header. The SPI identifies the security parameters in combination with the IP address, the sequence number used to prevent any replay attacks. There's some payload data which encapsulates the data. There's padding used to pad the data for a block cipher. Pad length necessary to indicate the size of the padding. The next header identifies the protocol of the transfer data. The authentication data contains the integrity check value ICV to the authenticated packet. Then IPsec can have two modes of operation, either in the transport mode or the tunnel mode. In transport mode, only the payload of the IP packet is usually encrypted and or authenticated. The routing is intact since the IP header is neither modified nor encrypted. However, when the authentication header is used, the IP addresses cannot be translated, as this will invalidate the hash value. The transport and application layers are always secured by the hash, so they cannot be modified in any way, for example by translating the port numbers. In tunnel mode, the entire IP packet is encrypted and authenticated. It is then encapsulated into a new IP packet with a new IP header. Tunnel mode is used to create virtual private networks for network-to-network communications, example between routers and link sites. Host-to-network communications, remote user access, and host-to-host communications such as private chats. The IPsec cryptography algorithm includes things like, and is defined for use with IPsec includes HMAC SHA-1 for integrity and protection and authentication, triple DES CBC or cipher block chaining for confidentiality, AES, which is Randall-CBC cipher block chaining for confidentiality. If you want to go into detail, RFC 4835 defines that. When we implement IPsec, it can be network to network, IPsec tunnel between two security gateways, using GRE IPsec in established layer 3 tunnel, L2TP IPsec tunneling established in a layer 2 tunnel, host to network such as L2TP IPsec in established layer 2 tunnel via VPN client on a remote client, for example your laptop or PC, an IPsec tunnel between a VPN client to security gateway, or host to host where IPsec in transport mode or tunnel mode between two competing machines. SSL or secure socket layer runs between the application layer HTTP, SMTP, NNTP, and many more examples, and the transport layer TCP. It supports client-server negotiation of cryptographic algorithms such as public key cryptography, RSA, Diffie-Hellman, DSA, and Forteza, or symmetric ciphers such as RC2, IDEA, DES, triple DES, or AES, and one-way hash functions such as MD5 or SHA. SSL works in two modes, either application embedded such as HTTPS, or SSL tunnel or SLVPN such as OpenVPN. Now, secure socket layer VPN, such as SSL VPN, is just less complex than IPsec. Unlike IPsec, SSL protocol sits on top of the transport layer stack. This means that OpenVPN, also known as user space VPN, because unlike IPsec, it operates outside of the operating system kernel, which is ring 0, as an application at ring 2. SSL is more flexible in supporting multiple cryptographic algorithms. Now, at the transport layer security TLS, we've got different versions, 1.1 and 1.2. TLS 1, transport layer security, is defined actually and based on SSL version 3. TLS and SSL protocols are not interchangeable, and the selection of TLS or CSSL is negotiated between the client and server at the hello command. Secure Shell is a secure replacement for the R programs such as R-Login, R-Shell, RCP, RExec. SSH uses public key to authenticate users and supports a variety of cryptography algorithms such as Blowfish, TripleDes, IDEA. SSH protects against eavesdropping of data transmitted over the network, manipulation of data at intermediate elements in the network, such as routers, IP address spoofing, where the attack host pretends to be a trusted host by sending packets with the source address of the trusted host, DNS spoofed of trusted host names and IP addresses, and also IP source routing. An example here, if you use a Windows environment, is PuTTY. Other countries record it as PATTY or PuTTY. Then network access servers, we have looked at this during the access control domain, previous domain. We have NAS, or network access servers, that provides centralized access control of AAA, which is authentication, authorization, accounting services. A distributed client-server security model, authenticated transaction takes place. Also, flexible authentication mechanisms can be used, interchangeable. There are certain versions of network access services such as TACACS Plus from Cisco, Radius, which is remote authentication dialing user service, now open source. Also the RFC 3579 if you want to look in more detail, and diameter, which is twice the size of radius. I think it's intentionally done like that, at RFC 4005. Now TACACS Plus, RFC 1492 defines it's a terminal access control and access control system. Plus, TACACS Plus is a significant improvement on the old version, and unlike Radius, TACACS is stateful, which means it's TCP based. TACACS is not supported by all vendors. In addition, TACACS protocol does not support authentication proxies, which means user authentication can only be stored centrally in a Cisco access control server. However, Cisco ACS does support authentication proxy to both Unix and Windows servers. Unlike Radius, TACACS encrypt the entire TCP packet and not just the authentication messages. When you look at Radius, a remote authentication dialing user interface, Radius server stores user ID and password and authorization parameter ACLs centrally. Unlike TACACS, Radius does support authentication proxies, so the user authentication information or schema is scalable. It uses CHAP or Challenge Handshake Authentication Protocol to authenticate the user. Client-server uses shared secret stored in the configuration file for encryption and decryption of CHAP, but not the data packets. It uses a single UDP packet designed for speed and performance. Diameter, RFC 3588. Diameter is designed based on Radius that supports mobile IPs. Diameter protocol supports NAS, mobile IP, roam ops or roaming operations, and also EAP. Operates peer-to-peer instead of client-server, supports multiple authentication proxies and broker models. Diameter supports both IPsec, mandatory, and TLS optional. And then finally, if we look at cloud computing is a new infrastructure that we can sell services, platforms, software, and network as part of a supplier model. So we have certain service models such as infrastructure as a service, IaaS, platform as a service, PaaS, software as a service, SaaS, network as a service, NaaS, and then also database as a service, DaaS. Now, some deployment models exist, such as a public cloud, whereby we can look at Amazon or Azure from Microsoft as an example. Community cloud, people building together. Hybrid is a combination between these two. Private clouds that we do personally ourselves. Then we can develop something from a company or environment and rent that out. And then personal clouds, where software you can look at is, for example, own cloud, to create your own cloud to manage your software. Issues that is around this is called privacy. Who has got access to your data? Compliance, who reviews that? Legal issues around this. Open source, as we see some companies coming together and define their own cloud computing standard. And this is the open standard that we see as, and this may actually create a problem that they would like you to buy into it and actually rope into their proprietary products. Security is an issue, sustainability, abuse. Some people purchase some cloud computing resources and hack other systems or attack it. Vendor lock-in may be an issue. Data protection, where's your data stored? Is it locally or in remote countries? Any physical controls you have no control about. Identity management, Physical and personnel security at the data center. Availability, we've seen Amazon and Microsoft and others going down. Application security, where's that controlled and where's the logs kept? Any privacy issues around this, and also legal issues. Now, the Cloud Security Alliance, it is in your information pack. There's a document that describes all these issues around that. So what we saw here is the basic concepts of the networking. We've looked at the OSI frameworks, ports and protocols, some physical devices, security controls and countermeasures, virtual private networks such as IPsec, really important. And we'll do an example that going through some practical experiences and how to set that up in a Windows environment. We looked at network access services and the new technologies such as cloud computing.